dimensions of a pure number. The given equation is dimensionally correct or false. And remember, displacement, distance, height, a scalar cannot be written using this method. Either initial or final velocity, it is LT minus 1. Hello students, this is SDsir again from the Temple of Excellence, Vidhyaashram, PU College, Mysuru. A new session, a new conversation, a new approach on dimensional analysis. What do I have for you all today from my bag of curiosity? It is the first application of dimensions. Wait. Have you all studied the dimensional formulae for different physical quantities? I had assigned this task for you all. I had worked out the dimensional formulae for 13 physical quantities, and I had asked you all to refer your textbook for a few more. I hope all you young guys have done the assignment given. Fine. Without getting late, let us jump into the pitch. We will study the first application of dimensional analysis. What is the first application that we study in today's class? In my today's class, using dimensional analysis, I will verify the dimensional correctness of a given physical equation. My dear students, what is that we do? We will use the method of dimensions to verify the correctness of a given physical equation. Using the method of dimensions, we will check whether the given equation is dimensionally correct or false, for which you have to first understand something called the principle of homogeneity of equations. I start with something called as the principle of homogeneity of equations, a defining principle in the study of dimensions. Homogeneity, homogeneous, something being same. The principle of homogeneity. Dear good friends, this principle states that any two physical quantities, any two quantities for that sense, can be added, subtracted, or equated. I can add any two physical quantities. I can subtract two physical quantities or equate them only when they have the same dimensional formula. Homogeneity, being same. What has to be same here? The dimensions of those physical quantities. So we understand from this principle that only those physical quantities which have the same dimensions, same dimensional formula can be added, subtracted or divided. So very clearly my principle says you can add two physical quantities, you can subtract two physical quantities or equate them only when they have the same dimensional formula. This is treated as the principle of homogeneity of equations. Now, under the core idea of this principle, we will check the dimensional correctness. We will verify the correctness of the equation. Yes, equals ut plus half at square. Coming in the next chapter, we will derive the three equations of motion. This is the second equation of motion. What are the terms involved in it? Yes, equals u into t plus half a t square. And what am I doing? Using my method of dimensions, using the principle of homogeneity, I have to verify whether this equation is true or false. Now, what is yes in this expression? Yes is the displacement. Yes denotes the displacement of the body. And remember, displacement, distance, height, length, radius, altitude, depth, all the quantities associated with measurement of length has dimensions L. Displacement of the body, yes, that is having the dimensions L. Which is the next term? U. What is U? Recall your lower classes. Somewhere if you have studied initial velocity. It is initial velocity. What is initial velocity? What is final velocity? In depth in the next chapter. Now just know this is some type of velocity. What is its dimensions? Yes sir, you have taught us in the previous session, LT minus 1. So velocity has the dimensions L, T minus 1. Next term, T, time. Basic fundamental quantity, dimensions is T. A, acceleration. Do you recall the dimensions of acceleration? Yes. LT minus 2. So I have explained all the terms in this equation with their dimensional formula. Yes, displacement formula is L. U, initial velocity LT minus 1. T, time capital T. A, acceleration LT minus 2. So I have given you the explanation of terms in the formula and their respective dimensions. Therefore, substituting them, dimensions of displacement L, velocity LT minus 1, time T, acceleration LT minus 2 T square. So this is nothing but S equals UT plus half AT square. Now I simplify. L equals this T minus 1, T plus 1 gets cancelled. L remains. When I simplify this, T minus 1, T plus 1 gets cancelled. What remains? L plus half T minus 2. T plus 2 gets cancelled. What remains? L. Again, L on the left hand side. 1 plus half 3 by 2. Again, L. Observe this now. Very beautifully on the left hand side, L. This is equal to 1 plus half 3 by 2 L. According to the principle, do I have same dimensions? So there is a 3 by 2 on the right hand side. Dear friends, I have mentioned this very clearly in the last session. I cannot write the dimensions for numbers. My dimensional analysis is not giving me any idea about numbers. So 3 by 2 is a dimensionless quantity. So left hand side L, right hand side L. So very clearly, by the principle of homogeneity, both dimensions are the same. The dimensions of the terms on the left hand side is the same as the dimensions of the terms on the right hand side. So very clearly, the given equation is dimensionally correct. Now students, we'll take up the second example to verify the correctness of an equation. And the equation I have considered is V equals U plus AT. Again, one of the equations of motion. V equals U plus AT, and using the method of dimensions, I shall verify whether this equation is correct or not. How do I do that? Again, sir, we use the principle of homogeneity. We check whether the dimensions of terms on both sides of the equation is same. If it is same, dimensionally correct. Else, dimensionally false. Now, in this equation, what does V refer to? Sir, my 9th standard, motion in one dimension, final velocity. Good. V represents final velocity. What is its dimensional formula? Either initial or final velocity, it is LT minus 1. I may either have initial velocity or final velocity, it is LT minus 1. Next, U, initial velocity. What is its dimensional formula? Again, LT minus 1. I repeat, either initial velocity or final velocity, they have dimensions of velocity LT minus 1. A, acceleration LT minus 2. LT minus 1 velocity ಆದರೆ LT minus 2 is acceleration. Again, T, time, which has the dimensions capital T. Again we substitute. See, the equation is V equals U plus AT. Substituting the dimensions, V is LT minus 1, U LT minus 1, acceleration LT minus 2, time is capital T. I have substituted the dimensions of all the terms in the given formula. LT minus 1 equals LT minus 1 plus T minus 2, T to the power 1, minus 2 plus 1 is minus 1. Again see, T minus 2, T to the power 1, minus 2 plus 1, minus 1, LT minus 1, 2LT minus 1. Again, what about 2? A scalar, it's a number. I don't write dimensions for it. So LT minus 1 equals LT minus 1. So beautifully, students, again, the dimensions of the terms on the left hand side is equal to the dimensions of the terms on right hand side. Very clearly, principle of homogeneity is satisfied and therefore it is dimensionally correct. The same way, now you will help me out. Third equation of motion, V square equals U square plus 2AS. Yes, work it out clearly. V, final velocity. Now don't worry about the powers. Let us first in simple describe the terms. V, final velocity, which is LT minus 1. U, initial velocity, dimensions LT minus 1. A, acceleration LT minus 2. Yes, displacement, which is L. So again, I have described all the terms in the given equation. Now substituting, what was the equation, students? V square equals U square plus 2AS. Again V, LT minus 1 but whole square. So LT minus 1 whole square equals U square again. LT minus 1 whole square plus 2A. LT minus 2, yes, is L. Now, LT minus 1 whole square equals LT minus 1 whole square plus 2, L into L, L square, T minus 2. I have just simplified the last term. L into L is whole square, T minus 2. Now, LT minus 1 whole square, LT minus 1 whole square plus 2, taking power 2 common, LT minus 1 whole square, LT minus 1 whole square, 2 plus 1, 3, LT minus 1 whole square. Again 3 is a dimensionless quantity. So again if you observe, the terms on both sides have the same dimensions. So again the given equation is dimensionally correct. Now, the fourth is an assignment for you all. I want you all to work out. I have chosen the equation P is rho GH. In simple terms, P is the pressure. I have given you the dimensional formula for pressure. Rho is the density, G acceleration, H height. Again use your homogeneity principle and show that the given equation is true or false. Now a very important concept, that is to write the limitations, flaws, disadvantages of dimensional analysis. The first flaw, the first limitation I've given you all already. Using the method of dimensions, I cannot write the dimensions of a number, a scalar. Dimensions of a pure number, a scalar, cannot be written using this method. So the very first limitation says you cannot employ dimensional analysis to write the dimensions of a number. Second one, this method does not give information about dimensionless constants. If there is a dimensionless constant, I cannot write the dimensions of that constant. And we cannot derive equations having trigonometric functions, log and exponential functions. If a given equation has a trigonometric equation, a log in it, or an exponential, for example in radioactivity, we write n equals n naught e to the power minus lambda t. I cannot derive this equation using the method of dimensions because there is an exponential term. So if my equation involves trigonometric functions, exponential functions, log functions, I cannot employ the method of dimensions. Hope you have understood today's session. Hope you pick up your notebooks, get few more equations, exactly the method I have solved, I have employed to use the application principle of homogeneity. Do that. You will understand the concept more in depth. Let's meet in the next session. Until then, thank you.